All right, good morning, everyone. Thank you for joining us for this week's edition of the Long Coffee Break. My name is Chris Visconti. I am a sales engineer on the Long Hydronics Plumbing and Steam Group. This morning we are joined by Trent Thurston from Superior Boiler, and Trent's going to be talking to us about the Cheyenne boiler line, which is our new offering of large capacity, high efficiency, dual fuel condensing boilers. Trent, take it away.
Hey, thanks for coming, everyone. I'm Trent Thurston with Superior Boiler. Superior Boiler manufactures out of Hutchinson, Kansas. We produce a full boiler line from the smallest to the largest sizes in both fire tube and water tube. And yes, we're talking about our newest product, which is the Cheyenne condensing boiler line. So one of the big things with the Cheyenne that separates it is our capacity. We go up to a 12 million BTU input. Our smallest is a 4 million BTU input. One of the biggest things with this is that it allows us to put fewer boilers into a boiler room and still meet capacity. So instead of putting 6 million BTU units in the room, we can put 12 million BTU units in. Again, if we have the full range, so if someone does want 6 millions, we can do that. This is a dual fuel high mass condensing boiler, and we're going to go touch on how all those affect boiler operation. So just a general review of what a condensing boiler is. They are more efficient than conventional boilers. That is why you will pick a condensing boiler. It gains this efficiency by condensing the water vapor in the flue gas. When you burn natural gas, depending on operation, it'll be about 13 to 18% water vapor in the flue gas, and we condense this to gain our efficiency. One of the things that we do have is we can have a large delta T. With conventional boilers, you'll need blend pumps to minimize temperature differential across the supply and return. And with condensing boilers, we actually like the large delta T because it allows us to get a colder water temperature. So it simplifies your piping arrangement. Now, as we can see on this graph on the right, to get the good efficiency that we're looking for, we do need cold water coming back to the boiler. At higher temperatures, you will not see any condensation, and your efficiency is basically the same as a conventional boiler. Now, since we do want this cold water coming back to the boiler, that does create certain design challenges for us that we address with our Cheyenne. The first is that the flue gas is acidic, so that water vapor that we condense into liquid water that's now having carbon dioxide in the flue gas dissolve into it. This forms carbonic acid. It's a relatively weak acid, but it still will cause damage to anything that's not designed to resist corrosion. So the other issue that we have with the cold water is thermal shock and sort of thermal stresses. These are caused by temperature differentials between the cold water and the hot gas. So we have potentially 100-degree water coming into the boiler, and the gas in the furnace will be over 2,000 degrees. So the differing rates of expansion cause thermal stresses. So with the corrosive aspect of this, all parts of the condensing section are made of 316 stainless steel. So this is a very good corrosion-resistant steel. One thing we really like about it is it's very weldable. You can get a very good job welding. That's going to come up important in this next slide. And also it can deal with high temperatures. So we will eventually get down to a very cold temperature, but part of this will see a hot gas, and some stainless steels become brittle when the temperature rises over 570 degrees. 316 is capable of higher temperature operation. We do have much thicker tubes and tube sheets than the ASME code requires. And the reason for this is, again, to get a good weld, so we have this material to weld on and give us a good weld. So for this thermal stresses, what we do is we have all full penetration welds throughout the boiler. So our tube to tube sheet joint, the tube sheet to shell, the tube sheet to furnace, all of these are done with full penetration welds. These are the best type of welds for dealing with thermal stresses. These allow us to flex, and so then it will absorb some of this thermal expansion as opposed to adding that as stress to the metal. As I mentioned, the furnace is going to be the hottest point with, again, over 2,000 degrees. And so this will obviously have the largest thermal expansion because the shell is going to be basically the temperature of the water, which could be as low as 100. So we have this U-shaped expansion joint formed from the furnace, transition plate, and furnace inlet and front tube sheet. This U-shaped joint will allow it to, again, flex even more than just the full pan welds would by themselves. And so this helps to, again, absorb that thermal expansion. As far as I'm aware, this U-shaped joint is unique to us in the condensing market. One feature we like about our boiler is that we do have a full-size furnace. So this furnace is going to be the same size as any conventional boiler that you see, the 5 square foot per horsepower regular boilers. This allows us to burn basically any type of fuel. So in addition to the standard gas and propane that you see all the time for condensing boilers, we can burn fuel oil, and we have also sold a project where we're burning jet fuel, which helps. It's helpful since at an airport and they have jet fuel available. Several of the other condensing boiler competitors will have a very small furnace, which is designed specifically for a mesh head type burner. While we can use a mesh head type burner and do offer that, we're not restricted to it. This mesh head has a kind of niche application with in the small furnace. It has a very cool flame, which allows the small furnace size. How it achieves this cool flame is it has a very high excess air level. Excess air causes a couple issues. One is that you're heating up unnecessary air, and so you're wasting energy by doing that. With condensing boilers, there's another aspect, is that you get better condensation with lower excess air levels. So as we see, when we get higher excess air levels, the water vapor in the flue gas goes down, percentage of that. And so this, when the condensing point, it starts at the return water temperature and water vapor concentration. At high air water vapor concentrations, we'll start condensing earlier, as you see in that graph. So when a 15% excess air burner, like what we can use in the Cheyenne, will be slightly condensing. Potentially a higher excess air burner would be not condensing at all and still stuck at the conventional boiler efficiencies. One thing to note on this is that 1 pound of condensate recovers about 1,000 BTUs. So with our example here at 100-degree return water, 50% excess air will recover 5.4% efficiency with that 54 pounds we have. The higher excess air potentially just gets 47 pounds, which gives only 4.7% efficiency. Now, yes, this is a good gain, but 4.7% is good, but it's not achieving all it can do with the full aspect of a condensing boiler. One other feature that we like with the Cheyenne is that it is a high mass boiler. So when we say high mass, what we mean is high water volume. So this high water volume changes temperature slower, particularly when there's a changing load. So when there's not a constant load throughout the entire day, the burner will modulate up and down to try to keep the temperature going out at the set point. Since we have a larger water volume, the burner has more time to modulate down when the load drops. What we want to avoid, and will happen, is the tripping the high limit, which causes the boiler to cycle. Cycling is about a 2 to 5 minute process. It will happen where there's a post-purge where the blower motor blows air through the boiler and out the stack, has to wait for a new call for heat, and then goes into pre-purge where it again blows air through for safety reasons, so there's no combustibles in there. But this purge cycle has this cold air, room temperature air, pulling out of the heat out of the boiler. And so each time you cycle, you are sending heat and money out the stack. Another aspect of being a high mass boiler is we do not require a dedicated boiler circulating pump. We can use a variable primary system. Now, if the end user does prefer a primary secondary system, we have no restrictions there. They're perfectly fine to use a primary secondary, but we have this added flexibility. Finally, we have the ability to safely shut down in case there is a no flow condition. Now, if there's a no flow condition, obviously no heat's going out of the boiler, so it's not producing useful energy for us. But due to our large water volume, even if there's a system failure that causes a no flow condition, the temperature will rise slowly, but enough time so the boiler's high temperature safeties shut the burner off, and we still have a safe operation. Now, this is a picture of the boiler with the jacketing and insulation removed. One thing to note, these are 2 different vessels that bolt together. So we have bolt together at the riser connections and then at the front with the smoke boxes. So this can be separated, and each vessel has forklift points and lifting lugs on there. So if there is a tight installation location, this can fit through a standard width double door, assuming that middle bar is removed. Each boiler can be moved in separately and then reassembled inside the boiler room. Our standard way of shipping this is to have fully jacketed, fully assembled with the temperature controls and low water cutoff fully factory wired and mounted. The only field hookups that you should need would be the outlet and return connections, and then your safety valves and vents. One of the final thing I'd like to point out on this is we do have these handholds and inspection points on each side, which will come in handy on this next one, talking about our inspection. So one of the things that we do like about our boiler is that we have a rear sight port in that davitted and rear opening rear lid. So for a sight port, everyone does have the one at the burner at the front, but the rear sight port gives another angle for a burner technician if there's, and so they can help with the commissioning and any maintenance or tuning. They get this rear sight port will give them a better picture and let them get a better idea of what's happening inside the flame and combustion. The other thing with that door being able to open is we can access the furnace and burner head without removing the burner. So if you have, in several other competitors, they'd have to remove the burner to do anything, work on it, or to inspect the furnace. And this requires removing the gas train and several other steps that are not needed with the Cheyenne boiler. We do have fire side access at the front and back on both top and bottom vessel. And as I mentioned, those 8 handholds can allow for water side inspection from only one side. So what this allows us to do, it allows us to put pairs of boilers with as little as 4 inches apart. Now, each pair of boiler will need a maintenance corridor on each side to allow space for the door to swing and also to, again, for that maintenance and inspection. We do show 2 different ways of door swing clearance. On the left there, the door is opened first and then rotated on the pin at the very end. Opening it this way gives the minimum rear clearance in case there's an issue with clearance at the back. On the right side, we start rotating on the pin as soon as possible, which gives us the minimum side clearance if that's what's required. Yes, this door will spin both on the davit and also on the pin. Finally, with the burner options that we have, we aren't tied to a single burner manufacturer or even a single burner model. This flexibility we find very useful to us. As mentioned before, we have both single and dual fuel. We have low NOx sub 30 with a fire and gas oil package, and sub 9 with a gas only package. One of the things that we can do, since we're flexible with the burner package, is that we can oversize the burner selection to make rate of altitude. There are some trade-offs with this. We lose some turn down, but we'll still be a minimum of 4-to-1, and a larger burner will cost more, but it still will make rate at altitude, even at potentially up to 7,000 feet or higher. So the other thing that we have is we use Siemens standardized and Siemens controls. So the burner control interface will be a Siemens, and this is very helpful to integrate with our Siemens lead lag panel, or we can work with a customer furnished BMS if required. So this is our newest product, but we have tested it thoroughly. In about 2020, we built our test lab and tested these boilers since then. In our test lab, we have a cooling tower, which allows us to operate for extended periods of time. Another factor is we have our heat exchanger, because the boiler loop is a closed loop and requires different chemical treatment than the cooling tower loop, which is open and requires treatment for algae, among other things. VFDs and mixing valves on the coming out of the heat exchanger allowed us to set both the supply temperature, return temperature, and flow rate through it. And then we had an electronic data logger, which would measure gas flow, water temperatures, and flue gas temperatures, and allows us to monitor this at a later value. So in our testing phase, again, started in 2020, we first tested the longevity of the boiler and efficiency of the boiler and proved our design that way. Once we completed that, we worked with Underwriters Laboratory, which is a third-party safety certification firm, and this allowed us to prove that the safety controls work correctly on both the boiler and burner package. The next thing we did, witnessed by UL, was the DOE standard rating test, which goes from 80 to 180 at full fire. And what we finally did to give us a full idea of how a boiler will perform at part loads and at real-world conditions is testing at, let's say, 100, 140 at 50% firing rate. We stand behind our boilers with an industry-leading warranty. We have sold 60 of these, with 35 of them shipping out from our factory. And while this is our newest product line, we have 70 years of building with the National Board Boilers, over 170 107-year history as a welding company together. And with that, I'm going to turn it back to Chris for the closing statements.
Thank you very much, Trent. A lot of great information there. If anyone has any questions or would like any more information on the Cheyenne product line, please reach out to your Long sales engineer. And please join us next week when Josh Likes will be presenting on fabric duct solutions with KE Fibertech. Thank you very much for joining us and have a great rest of your day.